All right, so for section 8.4, you're factoring these special products. So the first type of special product that we're going to look at is the difference of two squares. So one thing here, this bullet point right here, this is where the word difference comes from because difference is subtraction. Both terms are perfect squares. So remember things like perfect squares. So you have 4, 9, 16, 25, and so on. And then there's two terms, okay? So if you look at right down here, this little kind of general form that if you can get your binomial to be written as an a squared and a b squared, then you'll be right away able to put it into this a plus b binomial multiplied by a minus b. So looking at example 1a, so your a squared is already good. So I'm going to write this right above a squared minus b squared. I'm going to zoom in just a little bit here. Okay. So now that means your a is x, but 25 is not written as a b squared. But 25 is a perfect squared. We know 25 can be written as 5 squared. So I'm going to replace the 25 to now look like x squared minus 5 squared. So this, you should see, looks just like this general form that I highlighted up there. So now I can identify that my a is x and my b is 5. So then I can go ahead and plug in to the form a plus b times a minus b. So that would be x plus 5 times x minus 5. And that's your answer. All right, so with all of these, it's really helpful when you know your factors. So if you look at the next one, you should right away recognize that, okay, I have my n squared already, so the a squared minus b squared. My a squared's already good over here, but this 16 needs to be written in the form of something squared. So we know that we're going to have 4 squared to replace 16. So I'm going to rewrite this as n squared minus 4 squared. So then again, it looks like this up here. So now I have n plus 4 times n minus 4. So why this works is when you guys go ahead and FOIL, so remember I was talking about foiling, it's just distributing. So you're doing n times n, which is n squared, n times negative 4, which is negative 4n, 4 times n, which is positive 4n, and then 4 times negative 4 is negative 16. So just when we FOIL or when we distribute and we're checking, we're combining like terms right here. But what happens when you have a negative 4n plus 4n? They cancel. So now you have just that n squared minus 16, which is what we had originally. Okay, so that's why this is working, because that outer and inner right here are a positive and negative of the same value, so then they end up canceling out. Okay? All right, so next up is C over here. So looking at this, remember we're dealing with the difference of two squares. So what I said about the word difference means subtraction. So what do you guys see here? M squared plus 100. So this is not a difference of two squares. So what this actually is prime. This is something that is not factorable because there's no way that if you guys did look at it as possibly the m plus 10 times m minus 10, remember when you would multiply the 10 times negative 10, that gives you negative 100. This is a positive 100, so that's why this doesn't work here. So we would say prime, not factorable. Okay, so moving on to G. This is where things can just get a little bit different. It's your a squared isn't set up and ready to go. So remember it's a squared minus b squared. So we have x squared is already good, but that 9 in front needs to also be written in the form of something squared.